So now that we've mastered actually the 5 or 6 parent functions, we're going to now look at the transformations of these functions, the transformations. And what you see at the top, I don't mean to scare you, ladies and gentlemen, you're in class right now. This is eventually what we're going to be looking at. I'd like to hit you hard. And it looks scary. It looks weird. We have an A here, we have a K here, we have a P, and we have a Q. And honestly, the A, the P, and the Q, you actually all should be familiar with. It's this one, the K, that you don't really need. Let's just go back a little further. A lot of you actually know what I'm doing. If I were to treat it as a vertex form of a quadratic from grade 10, a lot of you actually know it this way. So hopefully this looks very familiar. So some of you are slowly understanding. The title of today's lesson is translations of functions. They're called translations. Translate means to just move up and down or left and right. No diagonal movement, although diagonal movement could be broken down to components of up and down and left and right. Okay? So a lot of you understand this. Diagonals, we don't really count that. Those slopes, we call it rise over run, or straight lines. And so, sorry, it just saves me time when I'm writing things and I'm just looking at your sheet. It actually gives you the definition. So it looks at, it's called horizontal translation, I call it horizontal shifts. And I call this vertical shifts. Now, you might actually be taught differently, and just try to absorb everything. It's not different at all. You just might learn this as H and K, but a lot of you realize the format that I'm trying to get across here, if we have the function notation, this, when it's written in the brackets, x minus p, or this value p, or this plus q, these are the associated translation shifts. Okay. So whenever you see something here in the brackets, say that's a horizontal shift. So a lot of you realize, if you were to annotate this, I would say, hey, this is a horizontal shift, and this is a vertical shift. Now, what does that really mean? If you look at your table, and it says it in the handout, what are the effects? When Q is positive, it means in English it shifts up Q units, right? I just changed it. I like writing it my way. This hand is also fun. And if Q is negative, it shifts down. So some of you are remembering, you've seen this kind of writing before, right? With the quadratic. How about for horizontal shifts? Horizontal shifts. Notice it's kind of the reverse, and some students are having some trouble with this before. So when it's plus P, it shifts right, P units, and if it's negative P, it shifts left. I think that most students in grade 10 and 11 find this difficult, so I even like putting it in the brackets. So in this case, you would see it written as this. Everyone agree? This means it shifts right P. And this one, x plus P, it shifts left. Before we continue, everyone okay? So that's in the notes that you have in there. And now we're going to actually take a look at example 1. But there's a subtle thing that we have to talk about. It's a new technique. We've seen it before, I think, from the PowerPoints. And you've seen me actually show it before. We're now going to illustrate it further. Don't get me wrong, this is for those students that can't really describe things. It is very useful, but there is what's called a mapping rule or mapping technique that will assist you to figure out the new critical transformation of those key points. So if we have a point, what we're going to do is this is actually going to be affected by plus or minus P, and this is going to be plus or minus Q. So example 1, let's just read the question. Given f of x equals x squared, sketch the following and determine the function, domain, and range of mapping rules. So for the first question, I just copied the question. This is the quadratic. And so that's why we have to know what this function looks like. So as a sketch, I'll just do it really quickly up top here. That's the parent, everyone agree? It looks like the parabola. And you already have it drawn in your handout, everyone agree? So it's already drawn. So you're supposed to kind of know it. So now, for question A, f at x plus 2, notice this is actually why you're taught function notation. So it's kind of cluing in what you need to, not translate, but it's the understanding portion. Can I get a volunteer to help us out from the class? What do you think this is? Is this a P or is this a Q? No pressure. Bridget.
P.
It's a P, right? Which represents a horizontal shift, right? Everyone agree? So even before we start, just to help some people out, this is probably a horizontal shift, right? Well, let's help some people out in English. What kind of transformation is it? Now, notice it's not vertical, so glad you understand. This is a P value. Can someone go further? It is a horizontal shift. Yeah, right?
2 units left.
Yeah, horizontal shift, 2 units left. So a lot of you already know, even though it asks us to use the mapping rule, a lot of you already know the orange parabola, the parent, I'm going to move all the possible critical points towards the left. And some of you already know as a sketch, I'm just going to do it really quickly. That vertex, which is 0, 0, is going to shift to negative 2 and 0. How about that negative 1 and 1? It's going to go to negative 3 and 1. How about that 1 and 1? That's going to go, subtract 1 minus 2, it's going to go to negative 1 and 1. And I think a lot of you know what I'm doing. And again, it should be congruent. And that's this function. So a lot of your understanding, I didn't even use the mapping rule. I just understood in English what kind of transformation has occurred. Took the original one, and I moved it to the left. So just for the people here watching at home, going to our left, I'm still here. Where's the left? Just shift it left and right. There's some questions here before we do the mapping rule. Hi.
Is F A?
F is not A. F stands for function.
Okay.
That's why it's a good question. I was waiting for someone to ask that. I said to you, there are, when I introduced this, A, K, P, and Q. Notice I didn't talk about X or
But
F.
then why is it like Y equals F at Q instead of F at Q equals F at Q plus Q?
Because this F at X is Y. That's how you've been taught, right? This is Y.
And why wouldn't you just write that as F?
Because, so it's good, I just don't want to, it has to equal something. Right, so the Y value is this representation. You're actually, this is just a formality, okay? Really what you're learning is this. Anything that you'll see in a moment when I give you an equation, for example, like this, you should be able to tell me right off the bat, even though you might not know what it looks like. This is a horizontal shift left 2 units. Okay, now we're actually jumping the gun a little bit, Sava, but this is also a horizontal shift left 2 units. This is also a horizontal shift left 2 units. This is also a horizontal shift left 2 units. And this is also a horizontal shift left 2 units. The scary thing is that I'm changing the parent function. Now don't look at this yet, because you're interrupting me for the flow. That's eventually we're going to talk about it. I could change these all to F at X, but that's what we're doing. And that's what I'm trying to do. I'm not going to do a table of values individually for you. And yet the mapping technique ladies of it will show up. And again, I apologize at home, you probably didn't see that. Because I don't really want to reveal this yet. Because this is the future lesson. This is the future lesson. Okay? So it will hopefully be clear in a moment. Flora, really quickly?
Yeah, just a question for the mapping rule. Isn't it AY plus minus?
Yeah, this lesson's only on translations. I'm going to add to it, okay? Just
I was like,
hold on.
Hold on.
That's right. So what we have for the mapping technique here, right? You don't obviously have to reproduce this all the time, but I'm gonna redo it for you. So with the horizontal shift left,
Isn't 4?
sorry, 4. If it's a horizontal shift left, what is that going to do? It's going to be the equation for the new x coordinate. It's going to be x minus 2, and that's going to be the remaining, the y values. So these y values are going to be 4, 1, 0, 1, 4. But the new values are going to be, I think everyone agrees, that's negative 4, negative 3, negative 2, negative 1, and 0, which I kind of missed. And then you could plot these critical points. And technically, it's all of them, right? But it's going to move to the left. Before we continue, everyone okay? So let's see it right now. Let's just pause the video. No, let's keep on. For question B, did the volunteer tell us? Notice Maria explained to us this was a horizontal it was, I think, Bridget said a horizontal shift, but Maria helped us out by saying specifically what transformation happened. Brandon, for this one?
Vertical shift to unit cells.
Nice, vertical. Is that guys right? Vert. Shift to unit cells. And so this time, I'm gonna let you draw it again yourself on your sketches if you want. But this time, and you don't have to reproduce this already because it's already there. Can someone please tell me what would be the mapping rule for this? No pressure. What do you think is going to happen? What would I write? I already kind of leading you, right? Grace?
+2.
To the which? X plus Y?
The y.
Yeah, the Y. Sorry. It seems obvious, right? So notice that P affects the X coordinates and Q affects the Y coordinates. And that's why Flora is actually understanding that eventually A and K are going to be introduced, but this is only a translation, so I don't want to, I like showing this, and we technically do everything simultaneously, but we're just trying to go slowly enough so that everyone absorbs it. So a lot of you realize the X coordinates are going to be the same, negative 2, negative 1, 0, 2, and sure enough, these are going to be the new values of 6, 3, 2, 3, and 6. And so we get a sketch with some of that. So again, this should be congruent, but if I were to describe from the orange one to the red one, and a lot of you already know, hey, wait a second, we did this on our test. Absolutely. That's why some of you realize these transformations are kind of continuing your mastery of what's happening. Okay. So we just did example 1. Any questions about that? Saba.
It's the same thing that we did in our other test, but like, why are we doing it all different? Like, why do we need that equation?
This equation?
Yeah.
You'll see in a moment. I'm trying to relate to our parent functions, but eventually we're going to have a function that we do not know the equation, but who cares? As long as we can have their key points. Now, if you really want to know where this is also used in the real world, it's in, for example, the facial recognition for your Snapchat filters. When they take the critical points or unlock your phone and everything, they're just taking key features, right? That's why I can't unlock your phone, you can't unlock my phone. Because it's taking the outline of my face, the biometrics, and that's what this is. Right? So that it's equivalent. If there's something wrong, you can get a tattoo, or if you have a scar or something, then the identifiers will not be there. So this is kind of what we're doing. Albeit, in math, it's easier. In real world, we need to use computers. We need to actually run it through a lot of organization. So that's what we're actually doing. And in fact, and I've said this before, it's used a lot in video games, right? So a lot of you understand a lot of the cloning of video games or like Mario World or whatever. Like Mario is the same kind of character. It's red hat, blue overall, red shirt. Right? Luigi, he's green, right? Also overalls, right? But purple is, Waluigi, and yellow is Wario. I'm getting that right, right? Okay. Anyways, so that's the whole point I'm trying to share, and that's what we get. So for example 2, let's try this with the translation of radical functions. Pause this for a second.